Hi, my name is Brittany, and I'm going to be talking about DNA repair in cancer, the role of HNPCC in DNA repair. HNPCC stands for Hereditary Non-Polyposis Colorectal Cancer. The modern term is called Lynch syndrome. What is HNPCC? HNPCC is caused by an inherited mutation in the gene that normally repairs our body's DNA. These are the symptoms of HNPCC. You can have rectal bleeding, stomach pain, cancer-related symptoms like weight loss and fatigue, and you can also develop POLPs, but it also can be presented without showing any symptoms at all. Now we're going to be talking about the incidence. The number of people affected by this are very small. People with colon cancer have an 80% chance of getting HNPCC. The normal population, it's 2%. The inheritance pattern of HNPCC is inherited autosomal dominant syndrome, meaning that the mutated gene is a dominant gene located on one of the non-sex chromosomes. You only need one mutated gene to be affected by this type of disorder. We'll be going over the function of the MMR without the outcome of HNPCC. First, I want to go over DNA replication. So this is a DNA strand, and these strands run the opposite direction. So the top one is 5' to 3', and the bottom one is 3' to 5'. And of course, the nucleotides have the complementary nucleotides. So G goes with C, and then A goes with T. So in order to do DNA replication, this strand that you see needs to be unzipped. So there's actually an enzyme that's called helicase that unzip these just like the image. Now these separated strands provide a template for creating new DNA strands. Now the enzyme primase makes a primer to mark a starting point of the new construction of DNA. Now another enzyme called the DNA polymerase binds to the primer and makes a new strand of DNA. And a new strand of DNA is going to be formed. But there can be problems. So going back to the DNA polymerase, it sometimes can make mistakes when pairing up the correct nucleotides with its corresponding nucleotide. For example, the DNA polymerase can pair up a A and a G or a C and a T. This is a mistake in the genome. Luckily for us, our body has some proteins to help catch any mistakes. So now we have the MMR, which is called mismatch repair. And the purpose is to repair mistakes in the DNA. So we have MSH2, MSH6, MLH1, and PMS2. And what we want to talk about is how MSH2 and MLH1 have protein products. And these protein products are called MUTS and MUTL. And what those protein products are, they act as detectives to find any mistakes. So what the MMR proteins will do is that they'll basically walk along the DNA strands to see if there's any mistakes. And once they find a mistake, they leave a warning, and that recruits the exonuclease 1, which is an enzyme, and this will cut out the chunk of DNA that has the mistake in it. Once the mistake is gone from the strands, we'll have DNA polymerase delta come in, and it will fill in the missing part. And then after the delta has finished, the DNA ligase will ligate the two parts together so they can form one strand again. Let's go over the function of MMR with the outcome of HNPCC. Let's talk about a what-if situation. What if something happens to the MMR proteins? So let's go back to the DNA polymerase. Like we said, it's not always perfect, and it does make mistakes. When there is a mistake, the MMR will take care of it. But what if something hinders the MMR activity? The epimutations actually silence these proteins, specifically the MSH2. When they are silenced, the MMR becomes defective and can't find the mistakes in the DNA. Also, the germline mutations that are inactive will also hinder the MMR and make it become defective. The MMR believes that there is no mistakes, so when there's no mistakes, the DNA strand will become copied many times over. With the increase of mismatch mutations all over the genome, this situation gives rise to MSI, which is microsatellite instability. A high MSI is a hallmark to HNPCC. Besides high MSIs, MMR defects also cause HNPCC. Unfortunately, there is no way to prevent HNPCC if you carry the gene. However, there are several different operations are currently available for the treatment of HNPCC. The three most commonly performed operations are as follows. subtotal colectomy with ileorectal anastomosis, total colectomy with ileoanal pull-through, total colectomy with ileostomy.